Halo Ukrida, saat ini saya sedang berada di auditorium lantai 7 Gedung E Kampus 1 Ukrida. Sesaat lagi kita akan menyaksikan expert sharing ke-7. Selamat menyaksikan.
Okay, let's start the lesson 4. Okay, the next one. Okay, maybe you have already learned C language. Yes? Yes, okay, no problems. In Poplay, nearly same comment. Here, maybe you know them. Do file statement. Yes. Or in these figures, we want to make 5 goals using a file statement. In this case, variable I, now we using a declare statement. Now I start from 0. So I equal 0. We declare here, and then we're using a file statement. File statement is the end of using an end statement. So the condition I is less than 5. This statement is used. First sphere, this is a position I 0, 0. So in the first, now is I equals 0. So sphere position is 0, 0, 0. And after making a sphere, one sphere, I is incremented. So I becomes 1. Now I is under the condition of I less than 5. So once again, this statement is done. So now is a position 1, 0, 0. So the sphere is created as a position of 1, 0, 0. So after that, I is incremented. So 1 plus 1. So I becomes 2. So this condition now is okay. So the sphere is made as a position 2, 0, 0. So this condition is correct. 5 spheres are made. After I becomes 5. After becomes 5. So I becomes greater than 5. This file statement becomes n. Yes. So please using this file statement. Using a cylinder statement, we can make this is a x-axis and y-axis and z-axis. So using a cylinder, very small cylinder, we can show each axis. in this case, I is less than 11, I minus 5, I minus 5, put in an I, first I is 0, so minus 5, 0, minus 5, 5, 0. A cylinder is constructed at this position, so minus 5, and minus 5, 5, minus 5, this one is. So this cylinder is made according to the y-axis. So I is incremented many times, so many cylinders are constructed like that. Okay, let's focus. Okay, thank you very much. In this slide, I would like to show you CSG. CSG are constructive solid geometry. To construct complex solids by combining primitive shapes. This primitive shapes is a sphere, box, cylinder, like that. CSG has 4 different ways. One is union, and one is intersection, and one is difference. The last one is merge. Okay, next one. Okay. This is an example of union. Union is union comment is who? Oh, this is no union. Sorry. This is two spheres. Two spheres is connected. Next slide, please. Now the union statement here. So two spheres combined and become one object. One object. So after using a union statement, this combined object moved and translate and rotated as one object. So if after using union statement, if use here translate rotation like that, if translate and rotation statement here, this combined object moved as a one object. Next one, please. Okay. So this is an example because there's a two objects after combined. The statement of rotate 30 degree in the x-axis and 45 degree in the z-axis rotated. So two spheres after combined becomes a one object. And this one object is rotated using this rotate statement. Okay, next one, please. Intersection. Oh, like a football. So the common part, two spheres for the first time, but after using an intersection statement, just only a common part is left. So the two spheres intersection make a common area, so it is constructed. Okay, next one. This is difference. Difference means subtraction. So this is intersection sphere and rotated. After that, cylinder. From the object combined two spheres, cylinder is subtracted. So the center part is subtracted by cylinders. So the hole is made. Okay, next one. Oh, if once again a cylinder here, like that image is made. Okay, next one, please. Okay, this one shows an example. Now, this figure is we give a name, length with hole. Length with hole is a difference and the intersection. Two spherical from the two balls, common area, common shape is like a lens. And this one is a difference from the lens shape minus or subtracted cylinder. So the center area is have holes. So we gave a name of this one object, lens with hole. Okay, next one. Yes. We declare lens with hole this one object, and one object is translate. Little bit, little bit, little bit, little bit. And this four lengths with hole is combined using a union statement. Okay, next one. Yeah, okay. Next one. Yes. And merge. Last one is a CSG comment, fifth statement. Last one is merge. Merge is the same as union. Okay, next one. This is N. Okay, thank you. Okay, so please start the movie. Yes. Oh.
In this lesson, I'll talk about rotations in a little more detail, color maps with a gradient, and image maps, which are a way to place a picture on the object. Once again, let's copy the camera, the light source, and the sky sphere from the previous lesson. So highlight all of that, and copy it, and create a new lesson, and paste that. And then let's make sure that it works the way we want it. Oh yes, have to give it a name, lesson 4. And that looks pretty good. Let me move this render window over a little bit. I want to tell you about rotations in a little more detail, and in order to understand that, it would be a good idea to have an x-axis and a y-axis and maybe a z-axis or a whole grid. We're going to simulate those with cylinders, very thin cylinders. For the x-axis, we're going to create a horizontal cylinder. So type cylinder, okay, start, end of cylinder. We'll make it go from, let's say x equals -5, y and z are 0. That's the base point. And go up to +5 in the x direction, 5, 0, 0. And we'll give it a small radius, let's say a radius of 0.3. And we need to give it a color, let's say pigment. Quick way to do that is pigment and just specify the color, gray. And we'll give it an ambience, that's a finish. Ambient, let's say 0.5, not sure what's best there. Let's take a look and see what this is. Okay, that's kind of a thick cylinder for the x-axis, so let's make the radius of that cylinder really small. Let's say 0.03 or 0.04. Let's try 0.04. Okay, that looks pretty good. So there's a cylinder in the x direction, and we need another one for the y-axis, so let's copy that. Copy and paste it down below. And change the base and cap points so they point in the y direction, so make x 0 and y -5 to 5. So x 0 and y -5 to +5. And let's see what that looks like. Okay, there we have it. See, so the x-axis goes from -5 to 5, and so does the y-axis from -5 to 5. Now, we could also put one for the z-axis, but I've already done that, and I set up a grid using the same idea, having a whole bunch of cylinders going horizontally and vertically. If we highlight what we just did and press the delete key to get rid of it, there, all that work and it's undone, I actually wrote a bunch of lines of code which I stored in a file called grid.inc. So if you put number include quote grid.inc, then I have lines similar to what we just did, but a bunch more of them, and it draws the whole grid. Let's take a look at this. So now I just have the camera light source and sky sphere, but I also included the code from this other file. Oops, I didn't delete everything at the end there. All right, let's try it again. And you see, there's my grid, and I extended X much further. Let's move the camera in a little bit. Let's move it into 20 back instead of 50 back. Get a better view of that grid. This white dot in the middle is that Z-axis coming in and out. We can see this better if I change the location. Let's say I move it 5 in the X direction and say 2 in the Y direction. Let's see how this looks. Aha, here you can see the Z-axis coming in and out. See, it starts at -5 here, and then it goes way out. I made it go much further than 5 out. Now, I'm going to put a box in here. Let's put a 1x1 box with the lower left corner at the origin. So let's do box, begin, end box. And let's specify the lower left corner at 0, 0, 0. And the right corner at 1, 1, 1. So that's a 1x1x1 box, a cube. 1, 1, 1. And we need to give it a color and ambience, so pigment. Let's make it red. And finish. Ambient. We'll use our old ambient 0.4. Let's take a look at this and see how it is. All right, there we go. You see that box. Let's move the camera angle. Let's zoom in on it a little bit more. Maybe look at the center of this box is at 1/2 unit because it's 1 unit each way. You can see with the grid what's going on. So changing the camera angle. Let's go in a little more, say -10. Instead of looking at 0 on X and Y, let's look at 1/2 on X and Y so we see the center of this. See if that's a better view. Oh yes, there, we can see what's happening with this box. Now the reason I wanted to do this is so I could show you how rotations work. So let's take our box there and rotate it in various different directions. Let's start by rotating it about the x-axis. So let's say I rotate the box 30 degrees about the x-axis. Okay, so it's going to spin around the x-axis. Take a look at this. See what happened? Now it rotated the 30 degrees towards the z-axis. Let's see, how can you describe that? If you use your left hand and point your thumb in the positive direction of the x-axis, this way, then your fingers curl in the positive angle of the rotation. If I change that to -30 degrees, it'll rotate the other way. See that? So the x-axis here is like the axis of rotation. Let's do it with the y-axis. Change the x rotation to 0 and make the y rotation 30 degrees and see what that does. Okay, so the y-axis is the axis that goes up and down. You see, so it's rotating out towards us. Notice the grid here is slicing it a little bit. If I do the y rotation -30 degrees, it'll go the other way. So you see it swung it back 30 degrees. And likewise, let's take a look at a rotation about the z-axis. Remember, the z-axis is the axis that goes in and out of the screen. Okay, so it rotates it like that. There's 30 degrees according to the z-axis. Again, if you point your thumb in the positive direction of the z-axis, which is back of the screen, then it shows your fingers curl this way. so it rotates that way. Well, that's what rotations do. Okay, the next thing I want to show you is how you can use color maps with a gradient. Gives you some interesting effects. We already did this with the sky sphere, and maybe I can make it a little more clear in this lesson by doing it on a box. So I took out the rotation, and I'm also going to take out this grid.include. Let me just comment it out in case I want it again later. Now, if you take that sky sphere, we had a pigment which involved a gradient. So let's copy that. And let's use that as the pigment of our box. So delete this pigment that we have there and paste this in. And let's see what happens when we run it. What did I do wrong? Let's see, no matching in the pigment. Oh, I didn't copy everything from the pigment. That's what I did wrong. Okay, let's try again. Aha! So you see the sky sphere goes from white, that was 0, up to blue, which is 1. Let me move the camera back a little, back to -15, and make the box twice as tall. So let's make the y go up to 2 instead of up to 1. Let's see what happens. And you see that pigment repeats itself. So what's happening with these gradients, the color maps, is they fit on a 1 unit tall area. And then if you go beyond that height, it repeats itself. We can make this pigment more interesting by putting another color in there. And the numbers have to range from 0 to 1. So let's put in a color at halfway, color red. And it should transition from white to red to blue. Let's take a look. Cool. Let me change the height of that box back to 1, so we're just looking at a single box. And notice how the pigment just sort of wraps around the whole box. Now, we specified the color map to have a gradient of y. Suppose I change that to a gradient in the x direction. Let's see what that does. See, now it goes x-wise, and notice the blue where it ends just sort of fills the end of the box there. Another thing you can do, let's go back to y. Another thing you can do with this is you can rotate the pigment itself. So before the close of the pigment, let's do a rotate. Let's rotate the pigment by the z-axis, 0, 0, let's say 20 degrees. Let's see what that does. Aha! Notice the bands repeating somewhat. Now, if I wanted it to go smoothly from one color like white down to blue at the corners, then I would have to do some rescaling. Let me show you exactly what's happening here. Let me change the positions of the red and the blue. And let's take out this rotate. So put blue in the middle and put red at the bottom. Just so we see what differences we get. Okay, so now we have red at the top and it fades to blue and then becomes white at the bottom. And let's put back that rotate. we still get these bands here. If I rotate it negative 20 degrees instead of 20 degrees, then I get the bands like this. Suppose I wanted it to transition from white at the lower corner to red at the upper corner. The problem is that we have to scale this gradient somewhat, and I can show you what's happening with a couple of diagrams. That gradient can be thought of as a horizontal rectangle there that transitions from white at the bottom, that's the 0 position, to red at the top, which is the 1 position. And the box that we're putting it on, the box is that square in the middle there. Now, when you rotate it, then the rectangle doesn't quite fill the box because the upper corner there needs a repeat of the rectangle, and that's why you're getting that. Actually, that's rotation through the negative angle as far as the z is concerned. If you want to make it fit the box, what you have to do is you've got to scale it, make it a little bit bigger. And I worked out the math for that. The correct formula for a 1x1 box, the correct scaling formula is actually this. Looks a little complicated. It's the cosine of an angle in radians plus the sine of the angle in radians. Now remember, we actually rotated it through an angle of negative 20 degrees, but the A that you use in this formula would be 20. And let's go back to the program and try that out. So what we need to do before we rotate this gradient is we need to make it a little bit bigger. So we're going to put in scale, and the formula that I had was COS parentheses radians parentheses the angle, which is 20, plus, oh, I didn't close the final parenthesis there, plus SIN, that stands for sine, radians, same angle, with 20. And let's see if this works. Aha! See? So now I've got the left corner as white and the upper right corner as red. And so if you want the gradient to go sideways somehow at a certain angle, then you have to do that scaling part first, and then do your rotate. The scaling makes it big enough so it fits on the unit cube. Now, if you don't want it on a unit cube, you want it in a box of a larger dimension, what you would do is make it a unit box like this, and then you would scale it however you want. You could scale it vertically, you could scale it horizontally, or both ways, or whatever. Let me show you how you might do that. Suppose I want to make this box a little bit bigger in the vertical direction. Then you would say scale, that's the y direction, 1 in the x direction, let's say 1.5 in the y direction, and 1 in the z direction. That'll make it a slightly taller box, you see? And since we already put the gradient on it, we're scaling the whole thing. The whole box that includes the gradient. Another thing you can do, instead of using a color map for the pigment, you can use what's called an image map. And that allows you to put a picture on the object. Let me change the scaling of the box back to 111. Like anything, you have to put it on the unit surface, one that extends 1 unit in the x and the y directions. Now, I have a couple of pictures that we could use. Let me show one of them. The image on the right here is a picture I took at the Isotopes baseball park, and the actual dimensions, which I read from my computer of this image as a JPEG, are 722 by 1113. Those are pixels. That information I'm going to need when I scale the box. So let me show you how you can put that picture on the box. So in this pigment, we'll take out the gradient and color map stuff. And we're going to put in that image. And the way you do that is you specify what's called an image map. Image map. You can always look up the syntax of this in the help menu, but I'm copying over from what I did on paper here. Let's see. Image map, and then set brackets, and you specify the file. It's a JPEG file. They spell it JPG. And I called it isotope 1.jpg. And I think that was a capital JPG. I don't know if that makes a difference. We'll find out in a moment. And close the image map there. Let me move this over so it makes more sense. And let's see what this does. Aha! There it is. Notice it's kind of squatty. Now here's where that size information comes in handy. What we want to do is we want to scale the box in the X direction, the first number of that image, which was, I forget what it was. Let me look that up. Oh yes, that's 722 by 1113. And let's think about it. We got the X is 722 wide, and the Y is very tall. Let's see, the Z should be the same as the X. Now that's a really huge box. We'd have to move the camera way back. I don't want to make it that big. So what I can do is divide all these numbers by something. Let's say I divide by 1,000. The middle number is a little bigger than 1,000. Then I'll have the correct proportions for it. And there you go. Now it's the exact same proportions as the picture has. And notice that it continues around what was happening on the left side. That's how you put a picture on it. I could also scale it once again. Let's say I want to make the box a little bit bigger, like 1.5, 1.5 times as big as that. I could do another scale on it, and I get a bigger box. And that's the essence of putting pictures on your objects. In the next lesson, we're going to do that with cylinders and maybe a sphere. In this lesson, I'll talk about
Okay, before following the video, one attention. Please open lesson folder of lesson 5. No, this one, okay? No, this one, okay? Yes, you can see many photographs. One is JKT48. Okay. Oh, no! Please don't touch. Oh. Close. Okay. JKT48 1 and 48 2. And C, no, don't. And there's C1. No, C1. Oh, okay. And next one. Cross. Yes. And next one. Yeah. And next one. Okay, this is final image. Okay, please close. Close the folder of lesson 5. Okay, please go to the maybe a document folder you have. Yes, maybe in a document folders, your program Poblay is here, Poblay folders. Please open here. Now this version is 3.7. Please open this folders. Yeah. Now it's include folder, ini folder, scene folder. Please open scene folders. No. Please open scenes folders. So go to down. So now here is maybe a program now you have made in the scene folders. Now here is lesson 1. Okay, please put okay. Okay, this is now you have made. Okay, please close the Poblay. Okay, so go back to folder of lesson 5. Go back to lesson 5. No, lesson 4. Yes, please open. So please copy the image. Yes, JKT48 or 40. Copy and go to Poblay folders of document. Yes, and Poblay folders, and please open. And scenes, okay, go down, yes, and please paste here, okay. The image must be set in these folders, in the same folders. So if you want to use another images, please put in this image. Please put in these folders. Okay, so please follow and make a program according to the video instruction. If please open the lesson 5. No, lesson 4. Please open lesson 4. Yes. Please open the folder of program lesson 4. Okay. Yes. In these folders, I have already made the programs. So if you want to quickly try the program is okay or not, 1, 2, 3, Word document. In a Word document, there is a program, and also the video lesson 4, 1, 4, 2, like that. This is a program in a also was in videos. So please try one by one. And please start the video lesson 4. No. In the folders of lesson 4. Yes, start. Yes, of course.
In this lesson, I'll talk about rotations in a little more detail, color maps with a gradient, and image maps, which are a way to place a picture on an object. Once again, let's copy the camera, the light source, and the skysphere from the previous lesson. So highlight all of that, and copy it,
Go.
and create a new lesson. And, go up to +5 in the x direction, 5, 0, 0. And we'll give it a small radius, let's say a radius of 0.3. And we need to give it a little bit more, maybe rotation.
No, back.
Let's do it with the walk.
No, back.
And we need the p-axis coming in and out. See, it starts at -5.
Stop. Yes. Here you can read include grid, but there is no grid. Yes. At the time when this video was made, there is an include file of grid, but in the new version, grid include no grid. So you cannot write this statement here. If you write this statement include grid, maybe some document, there is no grid. So you cannot use this grid include file. Okay, thank you very much. So let's try by yourself according to the video. But grid include file now is not used. So I recommend you according to my document in the program folders, one by one. Go to the last session. Maybe that's it. Okay, start. Stop.
1,000.
Stop. This JPEG image is isotope 1 is not here. So please use JKT1 or some other pictures. This picture is not here. Okay, let's start the last lesson of today. Tomorrow, I would like to show you how to make an animation. Okay? And at the time, free software made Microsoft Movie Maker. Movie Maker can be downloaded from the Microsoft site. So now I will show you how to download this. Okay? Please show this. Okay? How to download. Please download. So open the Google or Yahoo or something like that. Wait. Okay, please see the screen. Windows, oh, not so fast. Windows Movie Maker. Movie Maker, free download. Sorry, please stop here. Wait. Now your computer is connected to Wi-Fi? No. 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 So, okay. So please see the screen. So remember, maybe in your house or some other rooms, please try to download Movie Maker. Please try to download. Okay. Yes. Okay, please try. Yeah, it's okay. So this is window movie makers. Now it's open. So please prepare this movie maker until tomorrow morning. Okay? Okay, thank you very much. So please open up file of lesson 5. Yes. But maybe just maybe a movie. Yes, it's okay.
Other ways that you can map an image onto a curved object. We'll start where we left off on lesson 4. Instead of copying everything here and then pasting it in a new folder, what we can do is go to File and Save As, and we'll call it Lesson 5, LES 5. And that way we can change things in Lesson 4 without actually changing Lesson 4, so we have Lesson 5. Now, I want to point out a couple of details that I didn't mention before, or one detail anyway. In the light source, I put in the statement shadowless here. Now the reason I did that is when you see the grid, if the objects throw shadows on the grid, it gets a little confusing. So you can add the keyword shadowless to a light source, and that way different objects will not throw shadows on each other. I want to put the grid back because we're going to look a little more closely at how we put images on things, and take the scaling out, and we were using the isotope 1 picture. So let's take a look at what we have here. Okay, so there we see our box, and I want to look at what happens when we rotate this box around. Let's say we rotate it 180 degrees. That way we can look at the back of the box, 180 degrees by the y-axis. So 0, 180, 0. And that way we can look at the back of the box. And you notice that the figure is facing in the other direction. So when you put an image map on something, a regular image map, you get a copy of it on the back side of the object, but the copy is reversed. Let's change our box to a cylinder. Let me take that rotate out first. And let's see, we call it a cylinder, we type cylinder. And the cylinder needs a base point, a cap point, and a radius. So let's see, we want the base point to be right at the origin. No, let's move it over half a unit in the x direction. So 0.5 in the x direction. The cap point should have the same x coordinate. We want it to be 1 unit tall. And let's make the z correspond to the x. And we need a radius. Let's give it a radius of 0.5. And that should make the cylinder equivalent to the box that we had. You can double check that. Let's run it and see what we have here. Oh, I did something wrong because it's kind of tilted. What did I do wrong? Oh, let's see. The base point has x is 0.5. Y is 0 up. I want y to go 1 up. Oh, the cap point should have z equals 0. There we go. Okay, so that's in the same position the box was. And if we rotate it by 180 degrees across the y-axis, we see the image is backwards. So it's wrapping that image around the cylinder. Now, taking out the rotate, there are different map types that you can use in Power, specifically 2. The standard default type is a flat projection of the image on the object. If I say map type, if you search the help file for map type, you can see what this is. Map type 2, according to the help file, is wrapping the image around the cylinder. Now watch what happens here. So that entire image is wrapped all the way around the cylinder. If I rotate it, it's not going to illustrate too much here. Let's see what we get. Okay, it's a little hard to see what's going on. So what I'm going to do is I'm going to change this to a test image that we can use to see how these things actually look. I made a picture called Test A1, and we'll try that on the cylinder. Let's change the name of the picture there to Test A1. And let's take out this rotate, for the time being anyway, and see what happens. Okay, we don't see much there. So let me take out the map type so that we have a flat mapping like we had before. And there we can see what's going on when it repeats itself on the other side. Let me rotate that a little bit. Let me not rotate it through 180. Let's rotate it through the same 90. And see, whoops. Okay, see, so we can see where the thing's repeating itself here. You get a backward image on the other side. I want to put that map type back again, and I have another file called Test A2 where I duplicated the picture and reversed its direction. So you can see what I did here, and we're going to put that image on our cylinder and see what it looks like. So change that to Test A2, and let's take out our rotate here. Now you can see that something very strange is happening. Let's rotate it through 90 degrees, maybe get a better idea of what's going on here. Oh, 90 doesn't really show what's going on. Let's try negative 90 degrees, maybe 180. Aha! So what's happening is that entire image is being wrapped around the whole cylinder, and we should see the front side and the back side of that image. If we rotate it, say, 180 degrees, then the whole image is wrapped around this cylinder, maybe negative 90 degrees. We'll play around with different rotations to get an idea of what's happening here. Aha. So apparently what's happening is we've got the image all the way around the cylinder, and this image actually has two images on it. Let me take this map type out. I'm going to take the rotate out for the time being so that we get a flat projection. And you can see what's going on here. Now we're actually getting four images because we have two in front and two in the back here. Okay, this is getting a little confusing. What I want to show you is how the cylindrical mapping compares to the straight flat mapping. So let's take out this grid and let's go back to the image map for test A1. That's where we have a single instance of that picture. Let's see what we have there. Okay, there's our cylinder with the flat mapping. Let me do something with that. Let me move it. Let me do one other thing here. Let me make the cylinder open. Let's see, we have to say that before the pigment, I believe. So that we can see what's happening on the other side of it. Maybe move the camera angle up a little bit so that we can see better what's going on. Let's move it up 4 on the Y. There, so you can see that the image is wrapping around this cylinder and reversing itself on the other side. Okay, what I want to do is compare that to the cylindrical mapping. So let's copy this. Let's move it back a little bit. Maybe translate it. Negative 0.5 in the x direction. That will put its center axis right on the y-axis. And then I want to make another copy of it and put it on the right side of that. So let's copy the cylinder. Oops. Okay, I'm going to do Control C and then paste it once again, paste another Control V. I want to translate this one to the right somewhat. I'm not sure how far. Let's try 1.4. So I've got two copies of the same cylinder here. I'm going to change the second one. Okay, that's a little bit far. Maybe 1 unit. Okay, they're easier to see this way. What I want to do is change the second.
Okay, until 4 o'clock, we have a free time. So if any questions, please give me. I would like to answer to your questions. And maybe a Superman, maybe a Superman as a here. Okay, please see the video. Lesson 5 and follow according to the video. But in a folder of lesson 5, I have already prepared program lesson 5. Please open the folder. Please open. Yeah. So please push some. Please open. Yes, okay. So the program is start automatically and please run. Run. Okay, like that image is constructed. Okay, close. Close overlay. Okay, please start lesson 5-3. This one. And please run. Oh, like that English can be constructed. Okay, please see the program like that. In this case, now there is no grid file in the include. So we declare grid like that. Okay, please close. Okay, I want to see a JKT48. Please start this program. No. This one, video lesson. No, this one. Yes. This one is JKT48. Please run. Yeah, like that image can be possible. Okay, so close. Okay. So until 4 o'clock, I can accept any questions from you. Okay.
Jadi tadi yang dibilang katanya kalau ada ini udah selesai, jadi kalau ada yang mau nanya soal yang tadi udah dijelasin, pembicaranya bakal jawab sampai jam 4. Kalau ada yang mau ditanya, ada yang mau bertanya nggak? Mungkin dari sana ada yang mau tanya soal yang tadi dijelasin.
Liputan hari ini saya Nasenjaka melaporkan dari Ukrida TV.